Hi everyone! Welcome to this Markforged webinar presenting a step-by-step walkthrough of the Markforged 3D printing software. My name is Stephanie Koo. I'm a content engineer here at Markforged. I'm joined by Marco Madecki, our marketing specialist. We'll begin today with an introduction to 3D printing, including a description of workflow, what makes the Markforged 3D printing software unique, and how it can adapt to your company's security requirements. Then, we'll take a real-time look at the software's user interface and file management system, including its intuitive organizational hierarchy and an overview of features. From there, we'll dive into a complete walkthrough of printing a composite part, followed by a similar walkthrough of producing a metal part, all the way through printing, washing, and sintering. In the process, you'll learn how to see estimates of part costs, part weights, and print times. Finally, we'll wrap up with a live Q&A session where I'll do my best to answer any of your remaining questions. Real quick, before we go any further, if you haven't already signed up for your free trial of the Markforged 3D printing software, I highly recommend that you do so now so you can follow along with the walkthroughs. You should have received an email with links to the software trial and to the STL files that I'll be using. Let's do a quick review of the 3D printing workflow. Once you have a part in mind, you use the computer-aided design or CAD software of your choice to generate a digital 3D model. There are a wide range of programs available to suit all skill levels, and if you're crunched for time or inspiration, you can download one of the millions of free community-sourced parts available online. Either way, you obtain an STL file, which stores all the information about your part's surface geometry. Next, you use 3D slicing software to translate that information into G-code, which writes the printing instructions in a programming language that 3D printers understand. Send the G-code to your 3D printer and your part is ready to print. The Markforged 3D printing software makes these last three steps extremely simple by using intelligent slicing to achieve incredible precision and surface finish in both high-strength composite and metal parts. It's powerful, intuitive, secure, and accessible from anywhere. But what really distinguishes Markforged 3D printing software from any other software available is the ability to selectively reinforce any part with continuous fibers. Typical 3D printing involves building a plastic matrix that comprises the entire structure of the printed part. Our matrix is onyx, a nylon-based material infused with chopped carbon fiber for increased strength. In addition, Markforged has the only printers and software capable of continuous filament fabrication, which allows you to add long-strand fibers of carbon fiber, fiberglass, high-strength, high-temperature fiberglass, or Kevlar to the onyx matrix, based on your specific application. This elevates your parts to a whole new level of optimized strength and stiffness. In this photo, the black matrix is onyx, and the gold strands are Kevlar fiber. We also, of course, offer printing in metal, including stainless steel for now, with many more exciting materials under development. I want to emphasize that Markforged really cares about you and your parts. We recognize how important security is for your intellectual property, so we actually offer a suite of software options tailored to meet the requirements of any IT department. The most common option is our cloud software. It includes the full set of features, cloud-based file management, direct communication with printers, real-time monitoring, and frequent software updates. Markforged does not have any access to any of your information. It lives within your organization, protected by build file encryption and two-factor authentication. But for an added level of security, we do offer local storage software. With this, we do not transmit your STL files, build files, or other part information to our servers. All slicing occurs locally on your internal network. For maximum security, we offer on-premise software. It's exclusively a slicer with limited features and software updates only once per year. However, it operates completely offline, so it may be the best choice for maximum security agencies without internal networks. We recommend the cloud software for the vast majority of users. It's easy to get it for free on our website. Once again, the link is below. At last, let's dive in and see for ourselves what makes the Markforged 3D printing software so great. Alright. Log into the software and we'll go through the user interface. This is your library, which stores all the parts you've ever imported to your account. If you're part of a team, it will show all of your teammates' parts as well. To keep things organized, you can create project folders which are listed on the left sidebar. For example, I've got one project right now, and these are the parts inside. I can add a part from my library, like this bottle opener. You can create new projects simply by clicking here. Switch to view builds by clicking here. These are files that contain multiple parts to be printed together. Import new STLs into your library here. Various filters for viewing huge libraries are here on the upper right. If you're looking for a specific part, you can search for it up here. If you're managing a fleet of multiple printers, this is really useful. Click on this printer icon to see the current status of every printer in your network from anywhere in the world. You can register new devices here. Click on a printer to pull up details for real-time monitoring. Specifically, you'll see the temperature of each nozzle, the type of materials loaded, the name of what's currently printing, if anything, which layer is currently printing, if applicable, and how much time is left. It's good practice to check the volume of loaded material before starting a print, so you know if you have enough material to complete the entire print, or if you'll have to reload material mid-print. You can remotely control the printer using these buttons, namely to stop and preheat and cool. You'll also see if any prints are lined up in the queue and the history of past prints. The sidebar allows you to navigate to settings. One cool thing to check out is the dashboard, which gives you an overview of your network stats. You also have quick access to the printers in your network again. With that, let's go through the process of printing a composite part to either a Markforged desktop series or industrial series printer. It's the same, which makes it super easy if you have both types or are upgrading. So navigate back to your library, create a new project like Webinar Demo, open it up, and import an STL. I'll use this brake lever. This is an actual part for an actual motorcycle. You can imagine it undergoes frequent, repeated loading as the user brakes during every ride. You want to be able to apply a smooth, predictable force, so the lever itself needs to be very strong and very stiff, and it would be a bonus if it was lightweight too. We can give it a name. Here's the project name and a description for webinar on Markforged 3D printing software, and double check the dimensions to make sure they look right. On the right sidebar, you'll see part settings. Select the material to use for the matrix. We want onyx. And select the reinforcement material. This is the coolest part. It refers to that continuous fiber we talked about earlier. Pick whatever you want. Carbon fiber is appropriate for this application, given its strength and stiffness properties. Select the type of printer you're printing to. I'll use a Mark II. The grid displayed is the actual relative size of the build plate for the specific type of printer you selected, so you'll know if your part fits and you'll have a good idea of the scale. Now, part orientation. Say your part imported like this for some reason. If you mouse over the part, you can click on any face or even edge to set it to contact the build plate. Generally, you want to pick the largest flat surface, keeping in mind any holes, thin walls, reinforcement needs, or other special features. You can also do manual rotation. The goal is to eliminate supports, give the material the best chance for success, and get set up to add continuous fiber reinforcement for strength, so be thoughtful and intentional here. Let's hit save. Markforged 3D printing software will slice your part in the cloud and spit out estimates of print time, material cost, mass, and volumes. And that's it. You can stop here and hit print. You don't need to do anything else. But if you do want an extra bit of granular control, let's take a look at the other features. Expand the Part Settings tab. Turbo Print is a sweet new feature for Onyx-only parts that prints infill at double the height to save time without sacrificing quality. You can turn off supports if your part is designed to not need them. Expand thin features if your part has very fine, detailed features, but it's typically not worth the trade-off in dimensional accuracy. Use a brim if your part is prone to warping or has limited points of contact. For example, a part shaped like a table or a spider with spindly legs. Check your units and your scale. You can change layer height if printing without fiber, but we're printing with fiber, so our layer height is fixed. Here, if you have a registered printer on our cloud software, we default to slicing the part remotely on our servers. Under material settings, you can change the matrix infill and shell layers to optimize strength. Under reinforcement settings, you can change the same sort of settings for fibers. Concentric fill is great for reinforcing walls and holes, whereas isotropic fill makes your part stronger in bending about the XY plane by simulating the weave of a traditional fiber layup. Let's save again with our updated settings. You may be wondering if we can actually see the fibers inside the part. The answer is yes. Let's click Internal View. As before, we have our part stats on the left. In the semi-transparent model, we see our onyx without fiber in white and our carbon fiber in blue. If you selected a different fiber, it'll display in a different color. The layer bar at the bottom shows the material's distribution. Each segment is a group of layers that all share the same settings. Click on one to see the layer numbers included in the group. Here we have 4 fiber layers near the bottom, 4 near the top, sandwiched by 4 layers each of onyx for the external surfaces. All of this was the default setting we saw earlier, in our material and reinforcement settings. Those settings are not actually what we want for optimal reinforcement of this particular brake lever. It needs stiffness and strength all around, so let's change the settings. First, what I really want is a few different groups of concentric rings of continuous carbon fiber along all the outer walls. Our first and last 4 layers will remain onyx only. Drag the handles in the layer bar to change our first group to just include layers 5 and 6. In the upper right, we'll use concentric fiber in 15 rings, and the software automatically applies the new settings. Make a new group of layers 7 through 9, use fiber, set it to concentric with 10 rings, and create group. Make a big group of layers 10 through 85. Use fiber, set it to just 3 rings. And since it's fairly symmetric, we'll make a group of layers 86 through 88 with fiber in 10 rings. And a final group of layers 89 to 90 set to 15 rings. And we can delete the last default group by dragging the handles out of bounds. Click off in the black space to see the full part again. To modify a single layer, toggle to 2D view. Click around the layer bar to visualize how each layer is individually filled and reinforced. As with the groups in 3D view, you can change settings in the upper right. A super useful feature is this pause after layer. Toggling this on will instruct the printer to literally pause printing after the selected layer. This opens up a ton of possibilities for new assembly processes or inserting hardware components mid-print. Note that the part cools down during a pause, so if you intend to resume printing, try to do so within 15 minutes or so to avoid any inconsistencies. I'll add a pause roughly halfway. You'll see a pause bar has appeared just above the layer bar. That's it for internal view. Let's hit save. Go back to part view. Take a look at the versions on the left sidebar. You'll see a new version listed for every time we hit save. So if you want to clone a part, which is helpful if you want to modify a part created by a teammate without overwriting their settings, or if you want to revert to an old version because you accidentally changed something, you can. Versions are always saved with the part file on the cloud. And that's everything. So let's hit print. The next screen places our part in a build and gives us an opportunity to specify print settings. You'll definitely know you're in a build if you scroll to zoom out. You'll see the whole printer, which is not true when you're in a specific part. On the right, we select a specific printer to use. The drop-down list groups printers based on their status, and you can choose to export the build file if you want to print from a USB. You can pick any printer and will have the option to print immediately or send to a queue. Again, the software defaults to generating builds in the cloud. You can add parts to the build if you have room on the build plate. Click Add Part, and it brings up a list of compatible parts in your library. The number on the right indicates the quantity of that part in your build. Let's add one more brake lever here. The software arranged these parts pretty well on the build plate, but you can move them manually or specify numerical positioning and rotation. Try to place the parts as close to the center of the plate as possible for best quality, and look out for overlapping parts. You'll get a warning if the software sees anything off about the arrangement. In the upper left, you'll see an updated estimate for time, material volume, and cost for the entire build. When you're ready, hit Save Build to save it in your library. Hit Print to print. The pop-up screen repeats information about the print. You'll get a warning if your printer doesn't have the correct fiber currently loaded. We can add it to the queue if we don't want to print right away, but we do, so let's hit Print now. The Markforged 3D printing software brings us to the page for our printer, Mark II Demo. We see that our printer is currently preheating, and we get updated estimates as the print progresses. We can navigate away, do other stuff, and return to check on this print status at any time from anywhere. If something happens, like the print pauses or finishes or needs more material, we'll get a notification. It'll pop up either here under the notification icon, or in our email depending on our account settings, which you can change here. Our 2 carbon fiber reinforced brake levers are in progress. In about 8 hours, I'll go remove them from the printer and they'll be ready to use. Let's now walk through producing a metal part. Metal parts take 3 steps: printing, washing, and sintering. Printing is nearly identical to what we just did for composites, so I'll speed through it. We'll import our metal part, the impeller. Impellers are rotating components found in centrifugal pumps and turbine generators to change fluid flow and pressure. Their highly intricate geometries mean that impellers typically cannot be machined and must instead be cast using expensive custom molds. Or, with the introduction of the Markforged Metal X, they can be 3D printed using far less time and money. So let's orient this, and under Material, we want to select 17-4 stainless steel, our Sinter 1, and the metal series. Under Part Settings, check Units and Scale, and as before, we can save, take a look at the internal view, and print. Here's our metal build, where you can add more parts if you want. I'll just select our printer and hit Print. If your part uses supports, the software will figure out where to put them and how much release material to use. Alright, our metal impeller is printing on Metal X Demo, and in about 14 hours or so I'll have my part. It won't be ready to use this time. It'll be in what we call the green state, meaning it comprises both the metal matrix and the binding material. Step 2 is placing the green part in the wash to remove some binding material and stabilize the part structure. Let's click on the wash icon and go to the wash overview. All metal parts that have finished printing are listed under Ready to Wash, with an estimated wash time given. If it's not, you can manually add it from your library. Select our part, hit Wash Selected, follow the prompts. We'll need to use a scale, ideally with 0.01 gram resolution, to read the mass of the green part. We'll place our part in the wash, hit Done, and the timer will start. Our part will now be listed under Washing. Skip ahead by 1 day and our part is done. We should have received a notification in email. We can go back, select our impeller, and hit Dry Selected. In a few hours, it'll be done drying and we can record its final mass. Our impeller is now in the brown state. Still not ready to use, but ready to sinter. Step 3 is placing the brown part in the furnace for sintering, which causes the metal powder in the matrix to fuse into solid metal. Let's click on the furnace icon and go to the sinter overview. I don't have any furnaces registered to this account, but I recorded the process on a separate account in advance. Here we can see the status of those furnaces, including time left in the current process. All furnace controls are on the furnace itself. Each furnace run may contain multiple parts to fill the furnace volume for efficiency. Clicking on a specific furnace takes us to the specific page, including status, gas pressure, filter statuses, sintering progress, and history. We can remotely stop the run if needed. Once the run is done, our impeller will be ready to use. Fast forward, and here is what our finished parts look like. The brake lever in onyx with continuous carbon fiber reinforcement on the left, and the impeller in stainless steel on the right. So you might feel a little overwhelmed, but I promise that the software is really quite simple when you do it yourself. You won't need to change settings every time, or even ever, depending on your needs. Let's recap what we learned. First, we reviewed the 3D printing workflow, including where the Markforged 3D printing software fits in to make slicing, printing, and finishing your parts straightforward. Second, we looked at our software's user interface and file management system. Third, we walked through producing a composite part, including importing, selectively reinforcing with continuous fiber for optimal strength, and printing. Finally, we walked through producing a metal part, including printing, washing, and sintering. I highly encourage you to explore the Markforged 3D printing software on your own. You'll see very quickly how intuitive and easy it really is.